Okay. We're back in recording. Okay. Let's pick up where we left off. So how would we show, let's see how we would show these attributes in an ER diagram, an ER model. So we talked about these attributes in the previous hour, right? So the way that we could note that a primary key, that attribute is a primary key, would be through this little curly brace PK notation. You probably have also seen in some systems, if you looked at Microsoft Access, there's a couple of others, there is a little key symbol they will use. I will try my best to draw one here, but usually it looks something like this, where it's a little circle, right? And then it looks like this, and it has like a little teeth on it, right? So something kind of like that, where it's letting you know that this is the primary key for this table. So if we have a composite key, a composite primary key, then we would just have this little key symbol next to every attribute that is part of the primary key, or in this case, we would just have this PK notation next to every attribute that is part of the primary key. Okay. Some other things that we can note: this slash represents a derived attribute. Now, the reason why we need to note derived attributes is because sometimes derived attributes are columns in the table. Sometimes derived attributes are not columns in the table. We talked about using a view, for example. When we talked about using a view, we talked about whether to store data in a table or to use a view to calculate it at runtime. We talked about the trade-offs of the different ways to do that. A similar question, a similar discussion will have to happen for our derived data as well. Okay, it's how to store it. Do we store it as a column in the table? Do we store it some other way and calculate it when we need it? Okay. Okay. Some other things here. So here we have a composite attribute. We're going to tab in. So the address is the attribute we're going to call it. The parts that compose the address are these different parts here. We talked about addresses in Turkey having, in addition to a street, a city, and a postal code, I guess you don't call them a zip code here, probably, do you? A postal code. Instead of just having those three parts, there's more to it, right? There's a district, a mahale, an ilçe, all of that, right? I learned a few years ago that the building name, the cité name, is one of the most important parts of an address. Our post office was unable to deliver a package that my sister had sent from America because she did not include the cité name. She had the street, she had the building number, she had everything else except for the cité name, and the PTT said that they were unable to find our building because she had not put the building name on the address. So we learned that the building name is an important part of the address. Okay, so all of those would be the parts that would go together to make the address. Telephone number, this is how we would represent a multi-valued attribute. Remember, multi-valued means that we allow 1 to 3. In this case, it's 1 to 3. It could be star, meaning many, unlimited. A multi-valued attribute is simply saying that we can have more than one of these per instance of this. So a branch could have more than one telephone number. A person could have more than one telephone number. things like that. Okay, a branch could not have more than one address, just like our university, our department doesn't have more than one address. So the same thing is true here. So you don't, so it's not composite. This is how I want to make sure to point this out, that this is composite, means that multiple parts add together to make the attribute. Multi-valued means there can be more than one of those things for each instance here. Okay. All right. We do want to know the difference between a strong entity type and a weak entity type. Okay, so this is, in a sense, this has similar to the composite relationship in a UML. So a strong entity is something that doesn't depend on another entity for its own existence. A weak is something that depends on the other entity for its existence. So this is going to be important when we get into the different design phases. So this example here with a client who states their preference. Okay, the preference is the weak entity because it doesn't make sense for a preference of a client to exist if the client doesn't exist. So we're going to have to refer back to, I use that word refer intentionally, by the way. We're going to have to reference the client table to find out which client it is that has this preference. Okay, but a client can exist even without their preference existing. So they might have no preference, and that's okay. So client does not depend on the preference for its existence. I mean, I like kunafe. For desserts, kunafe is my preference. Does kunafe, I guess I shouldn't say does kunafe depend on my existence, because that's not, it doesn't. But my particular preference of kunafe depends on my existence for me to have it, right? But my preference for kunafe does not determine my existence, right? I don't exist because I like kunafe, right? My liking of kunafe exists because I exist. I don't know, are we getting into Descartes now? Are we getting into philosophy? Hopefully I didn't confuse you more with those comments there. I'm just trying to help you understand the difference between a strong entity and a weak entity type, because it will be important for how these entities and these relationships become tables and foreign key constraints in our final database system. Now, as I said earlier on, another thing is a relationship can have attributes. Okay, so for example, mesela, a newspaper advertises a property for rent. So we're going to advertise our properties for rent in certain newspapers. Every time that we advertise, right, our newspaper advertises a property for rent, we may have things like, what date did we do that on? Because if we advertise with a different newspaper, we're going to need to know what was a different date, what was a different cost, how much did it cost for this newspaper, how much did it cost for this newspaper to advertise a certain property for rent. So if we advertise the same property in 2 or 3 newspapers, we're going to want to keep information related to that advertisement for future reference. Because if newspaper A costs more than newspaper B, we may use newspaper B more often. Right? Okay, so something else that we may want to keep track of in this that's not here is how many contracts, how many leases can we say were a result of a certain advertisement? Because if newspaper B is costs less than newspaper A, but newspaper A results in many more leases and many more contracts for us, then maybe the cost is worth it, right? And so maybe something else we can we can keep track of down here is can we know which leases are a result of which advertisements. Okay. A couple other things here. Let's talk about some structural constraints. Right, multiplicity. And we'll talk about cardinality, multiplicity, right? So the multiplicity is the number of possible occurrences. So how many members can participate in a relationship? Right. So the most common the most common degree is binary, meaning there's one entity to one entity, so two entities involved, right? And we can have different types of relationships. We can have one-to-one, we can have one-to-many, or we can have many-to-many. So if we look at an example here, a staff who manages a branch, we would call this a one-to-one relationship. A one-to-one relationship. Okay. Notice this is not this. Okay, this is not the same as this. The dots up and down, a colon, is not the same as two dots side by side. So no, don't look at this. Okay, that's coming next. We'll talk about that in a moment. That has to do with cardinality. That has to do with whether or not a relation or an entity is required to participate in a relationship. Okay. But this is a one-to-one relationship. If there exists one over here, one member here, they can only have one over here. There is not a staff person that manages more than one branch. There is not a branch that is managed by more than one staff person. Now, that doesn't mean that every staff person has to manage a branch. Right? That's what this has to do with when we get to it. Okay, we're not there yet, but right now know that if there's a relationship between an instance of this entity, then it's only one on each side. Okay. All right. So how would we draw that in the ER diagram notation? Okay. Now this is where we get to those dots side by side. Okay. I don't want to cover too much up here, so let me erase it. All right. But this is where we get to those dots side by side. So the way we read this is that staff has a one-to-one relationship with branch called manages. Okay, so we call this a one-to-one relationship. So what about these other little dots and side by side dots and stuff? Okay, what's this 0 here mean, and what's this 1.1 and all of this? Okay, all right, so the ones on the right side tell you how many can participate in the relationship. So if there is a staff person, they can manage one branch. If there is a branch, it can be managed by one staff person. Okay. This is how many can participate. The other one, the other side, is how many must participate. Okay. So branch is managed by at least one staff. So the way we could read this is the branch is managed by one and only one staff person. The 0 says that staff does not require a branch. So staff does not have to manage a branch. So if a staff person exists, they can manage 0 or 1 branches. They can manage a branch, but they don't have to. So again, so the way we can read this up here, a member of staff can manage 0 or 1 branch. Each branch is managed by 1 member of staff. Okay. By the way, this could also be written as just a 1 by itself, right? If we see a 1 by itself, we understand that to mean 1 and only 1. Okay. If we mean that it's not required, that it must be 0.1, we have to write the 0.1. So these two notations, this and this, are the same. Okay. Questions about that? Before we move out to another relationship type? Or another, yeah. All right, I'll come back and check on it again and see if there's anything. All right. What about the overseas? The overseas relationship type. Meaning a staff person oversees properties for rent. So here we say that a staff person can oversee a property. A relationship represents that a property is being overseen by a particular staff person. A couple of things that we're noticing through this, right, is a staff person can oversee multiple properties, right? So they can oversee N relationships. But by this staff person, we understand that they don't have to oversee any relationships. They don't have to oversee any properties. What about this side? How many staff people can oversee a single property? How many staff people can oversee a single property? According to our example data. Right, this property is only overseen by one person. This property is only overseen by one person. This property is only overseen by one person. All right, so 1 is how many can, but is it required that a property has to be overseen by a staff? Right, there's this guy down here, right? That's not overseen, so property is not required. So now what we're going to see is when we go to change this into the ER model, this is going to swap, and we'll see that in just a second here. All right. Okay. So again, so the way that we represent this is we call this a one to many relationship, a one-to-many relationship. Dots up and down tell me what type of relationship this is. Basically, it tells me what the right-hand numbers are. All right, so a one-to-many relationship tells me 1 on one side, star on the other. Okay, it does not tell me what the left numbers are. Okay, so a staff person can oversee many properties. A property can be overseen by one staff person. But as we saw in the example in the semantic net, neither one of those is required. So a staff isn't required to oversee any properties. A property is not required to be overseen by any staff. So a staff oversees 0 or many properties. A property is overseen by 0 or 1 staff member. Okay. All right, let's talk about one more using a semantic net. All right. Wow, that's a lot going on, right? Okay. All right, let's talk first about the newspaper. The newspaper can advertise how many properties? According to this example data, according to this example semantic net, the newspaper oversees, a newspaper advertises how many properties, can advertise how many properties? Many, right? Yeah, a newspaper can oversee many properties, right? Okay, so a newspaper can oversee. Okay. According to this, how many properties must a newspaper advertise? Is a newspaper required to advertise properties for rent according to this example diagram? Okay, not to what our logical brain thinks, but according to this example diagram, a newspaper, there are no newspapers that don't advertise properties. Okay, we'll talk about why that is in just a moment. We'll get into why that is in just a moment. Okay, why this makes sense. Okay, so what about the other side? A property is advertised by, can be advertised by how many newspapers? All right, many again, yeah. Okay. And a property is, it must be advertised by, good question, Zara Selin. We'll get into that in just a moment. That is a great question, and we'll talk about why that is. Okay, but first let's get this left-hand number done. A property must be advertised in how many newspapers? What's the minimum number of newspapers that we can advertise a property in? All right, 0. All right. So if we go and we look at our ER model for this, here we say a newspaper advertises 1 or more properties. A property is advertised in 0 or more newspapers. Now, Zeta, you asked why not 1.2. Okay. Now, in our example data, yes, a newspaper, all the newspapers in our example data could advertise 1 property for rent, like the West News did. This was 1, this was 1, or it could advertise 2, like the Glasgow, this thing. I cannot ever pronounce that. Daily newspaper. Because we might not be seeing all of the details on this, we kind of use examples like this for saying how many it could be. right? Not necessarily for what we're trying to generalize. And if we say 1.2 like this, if this were 1.2, it would mean what we would be saying is that a newspaper can only advertise 2 properties, and once it's advertised 2 properties, we can't advertise any more properties in that newspaper. Well, we probably don't want to put a limit like that, do we? Because once a newspaper has advertised 2 properties, especially if it's been successful and gotten us some contracts, we probably want to continue using that newspaper, right? So 1.2 is saying specifically 1 or 2 only, and that's all it can be in the future. So once a newspaper advertises 2 properties, we're done. Okay. So currently, the example data we showed only had 2 properties for that one newspaper, but that doesn't mean that's necessarily how we're going to keep it for forever. Okay. Let's also talk about one other thing. Yeah, let's talk about one other thing, and then we'll move on. Is this whole newspaper is required to advertise a property for rent? Does that seem reasonable that we require all newspapers to advertise our properties? Are we requiring every newspaper in the world to advertise our properties? Does that seem reasonable? No, it doesn't seem reasonable. But we put this structural constraint here. No, English is so hard. Structural constraint. All right. We put this requirement that if a newspaper exists in our database, we must have them advertising a property for rent. Okay. Remember, we are designing a system with boundaries. We're not designing every newspaper in the world. What we are doing is we're keeping track in our database of specific newspapers that we have used to advertise our property for rent. We're not keeping track of every newspaper in the world. That would be why? If a newspaper has not advertised any of our properties, why would we keep their information in our database? That makes no sense, right? Excuse me. So if we have a newspaper in our database, it's probably, or in this case it is, because that newspaper has advertised one of our properties. So anytime we advertise with a new newspaper that we don't have in our database yet, right, then we add their information to our newspaper table. So this does not mean that we are requiring every newspaper in the world to advertise our properties. What we're saying is every newspaper that we have a row for, every newspaper that we have in our database is going to be required to advertise a property for rent. And basically what that represents is that we are only keeping track of, we are only storing the data for a newspaper if it's important to us, if the property, if they have been used to advertise a property for rent. Okay. All right. So make sure we understand that what these constraints represent is not the whole world. It represents the system we are designing, that if we've designed it well, that it has boundaries, right? And one of the boundaries here is we are not designing newspaper systems. We are designing a home property for rent system for the purposes of rental contracts. Okay. I hope that's clear. I'm going to skip over this ternary thing. Okay, but I will do this summary of these constraints, right? So summary of these multiplicity constraints. So, 0.1 meaning 0 or 1 entity occurrence, a 1.1, or as I said, or just the number 1 alone, all right, is exactly 1 entity occurrence. 0 to many, or just the star represents 0 or many occurrences, not required, but it can have more than 1. 1 ... star is 1 or many. Notice that these two, oh, I clicked off my pen. Okay, these two here give options for notation that doesn't involve the 2 dots. That's because they're used so frequently that it made sense to allow for a kind of a shorthand way of writing the same thing. Okay, this comes to your question, Zera, Celine, or is it Zera, Celine, doesn't matter. Make sure to call you what you would like to be called. This kind of comes to your question here is we can put something like this in where we say must be at least 5, cannot be more than 10. Okay, so there's a range here. So if it has this thing, if it has this relationship with this other entity, it must be either 5, 6, 7, 8, 9, or 10, right? Cannot be 11, cannot be 4. We can specify very particular values. So we can have 0, 3, 6, or 0, 3, 6, 7, or 8. Okay, so we can even define not just, one or many, right? We can't, or 0 or many or something like that, but we can define it using very specific notation about how it could be. That's probably not going to be a constraint that your DBMS is going to be able to enforce. It's probably going to be something you'll have to enforce programmatically through stored procedures or through back-end code or something like that. Most likely the DBMS on itself will not be able to enforce a constraint like this. I guess maybe some of them probably can. I've not used any that could, but constraints like this are easily enforced. Okay, and we'll talk about how to enforce them when we talk about database design. Let's see, was there anything else that we need to go over? Let's finish off here with the cardinality participation discussion. Okay, so again, multiplicity is made up of 2 types, cardinality and participation. Those are big words. I don't expect you guys to remember cardinality, participation, although participation is not that hard, but I don't expect you to remember these fancy big words, but cardinality, basically it's the maximum number. So remember that each part of that relationship is defined by a maximum number and then a minimum number. Right? So 0.1 means the cardinality, the maximum number of relationship occurrences is 1. Maximum number that can happen is 1. So the example we looked at was the staff manages a branch. The staff can manage at most 1 branch. Participation is the other side of that. Is it required or not? Does it have to participate in this relationship? If a staff exists, does it have to manage a branch? No. But the other side of that, the other type of relationship between staff and branch we had was has or works at, where a staff works at a branch, right? Does a staff have to work at a branch? So let's talk about that. Let's define the staff and branch entities. But now, instead of the manages relationship, we're going to use the has. The branch has staff. Okay. So question, let's talk about the right numbers first, the right-hand side numbers here first. Okay. Is a staff required, sorry, how many branches can a staff work at? So this one over here. How many branches can a staff work at? One, right? Yeah, I mean, I can't work at 2 universities, right? Well, I guess, I don't know, maybe some of our folks do some side work at other universities, but I'm an employee at 1 university, right? And our staff members are an employee at 1 branch. Okay, good. Okay, other side of that, over here. A branch can have how many staff? Yeah, a branch can have more than 1 staff. I mean, our university, our department has lots of staff people here, right? Okay, let's talk about these other ones. A staff can work at how many branches? If I'm in the university system, how many departments can I work in? Or sorry, have to work in. Sorry, I already said can. Can was over here. If I'm in the university system, how many departments do I have to work in? Yeah, I would think at least 1, right? Because otherwise I'm just a freelancer who's not, where am I? Right? Okay. So staff, we would say that the staff is required to participate, right? The staff is required to have a branch. All right. A little bit tougher of one here. Let's talk about this other side over here. If a branch exists, we've said that it can have many staff, but how many staff must it have? How many staff must a branch have? I mean, sorry, yeah, how many staff must a branch have? Ah, Oscar, you're using my it depends language. Yeah. Okay, what are some options? Okay, Sila says at least 1. All right, at least 1. Okay. All right. So, what if it's a new branch, we've just built it in town, and it doesn't have any employees at it yet? We haven't hired anybody to work there yet. Is that possible? Maybe, except because if the other relationship exists, that manages relationship said that a branch had to have one staff, right? Which means that one staff, that manager must be working at that branch. So yeah, so one, but if we don't have that manages relationship, then it could be 0, it could be 1, right? And what this reflects is what we call design decisions, right? So these are decisions that we make while we are designing a system that represent certain rules, business rules that may have to be followed, right? And that we may end up having to do things in the system to enforce them. Okay. So if we look at another example, a student and a course in a university system. Okay. So a student takes courses. Okay, so you register for courses and you take them. All right. Oh, by the way, this is, again, we call this a one-to-many style of relationship. Okay. All right. How many courses can a student take? Yeah, many. Okay. How many students can a course have? Yeah, also many. Now we could represent that as a star. We could also say there is a restriction of something. Let's maybe say 75, right? So you may say there's a restriction to how many that many can be. So we can't, we can't have a course with 3,000 students in it. That would be very difficult to teach, right? Okay. So if a student exists, how many courses do they have to take? What's the minimum number of courses that they have to take? For them to exist in our database, how many courses do they have to take? Yeah, I would probably think 0, right? Because if we require anything bigger than that, we can't add the student until we put them in a course somewhere. Well, what if we don't know what courses they're going to take in the first semester? All right. Okay. The course. All right. How many students must a course have? Yeah, it could depend on the course. And we could say that in order for the course to exist, we need, if there aren't at least 3 students in it, we are not going to offer it. Okay, that's a possible business decision we could make. We could also say, well, but even if there aren't any students enrolled in it yet, we still want to be able to do things like put a professor in there. We still want to be able to have it show up in the system or something like that. So even if there aren't any students yet, right, we still want to have the course exist so that we can assign it to a teacher, so that we can do different things, right? Right. And so like Metahan is saying, some courses don't open until a certain number is reached. So what this number now represents is a business rule, a design decision for our system, right? Because if we say 0, then we're saying we can have courses that exist even if they don't have students yet, right? If we put a number there, we're saying that a certain number of students have to be added to the course before we can have it be in the system at all. And that is both going to influence, it's going to be reflective of the requirements. What are the requirements? Do the requirements say which way to do this? Possibly, possibly not. Also, how we end up implementing the system and what constraints we have to put onto the tables and columns in those tables are going to be a result of how we design as well. Okay, so not only will we need to know what the requirements are, do the requirements say how this relationship should be defined? And if not, do we need to, is it one of those things that it doesn't matter? We can do it either way. Right? Either way is fine. Or is it something that we may need to go back to and talk to our customer about to find out what is it that they want? What is it that they need? Okay. And then on the other side of that, how we end up having to implement the system could be different based upon this decision that we make. Okay. All right, so we will end there for today, and we'll pick up tomorrow with more on multiplicity and cardinality, participation, those big fancy words that basically just mean how are these relationships defined between one another. All right. Any questions or comments before we end for today?
Have a good day.
Nope. Okay. Have a good afternoon, and I will see you guys tomorrow morning.